Hello folks, I'm Ed Overstreet and welcome to the Night Sky Imaging YouTube channel. Today I'm going to try something that's going to be kind of hard for me, and that is to keep something simple. I go off in tangents and I forget that a lot of y'all are looking at PixInsight for the very first time in it, and or you're just not comfortable with anything. And boy, I remember I was there, and how frustrating it is to have all the horsepower that PixInsight has and see all these other outstanding images going up, and knowing that your data is okay, but your know-how to get your data where you want it isn't. So I'm going to try to keep this just really down to the rock bottom fundamentals, and I'm going to illustrate just the processes that can, it's not just get you by, but PixInsight has some powerful processes. That's what they're called, and they're to be used. But you can produce an image with a very minimal amount of PixInsight understanding, and that's what my hope is today, and that is to take you from the calibrating, registration, and integration of your images in one simple script that's similar to Deep Sky Stacker, but this is part of the PixInsight package, and to prepare your linear image to be stretched permanently and in its non-linear state, to do those few tweaks that make your image pop and give you cause to be proud. So if I can do this, anybody can do this. And please understand, I am not a master of PixInsight. I have been struggling with it for an awful long time, but I am comfortable with what I know, and I can take with the things that I know, and I can do okay with image production. So that's what I'm sharing. I said a little prayer that I won't complicate it, and all of this was brought to my attention just recently when a member of our astronomy club downloaded PixInsight, and I told him if he'd stop by, I'll kind of run him through the things that I do. And I realized from his questions that it's really hard to keep things real basic, because you have a tendency to believe that or feel that these are all understood concepts. So I'm going to try to be as basic as I know how to be, and I'm going to review the video, and if it doesn't kind of meet that criteria, I'm not putting it up. I'll try to do it again. And by the way, I want you to know this is like my 8th attempt at doing just this video. I've had zero problems doing any of the other ones, but I'm not sure anybody understands the other ones. So here we go. Let's head over to PixInsight, and I need to share my data with you, and it's coming up. Okay. The first thing that I'm going to do is I'm going to open up by the way, I'm not going to spend any time going through all your menu choices and what all these little icons are. I'm going to show you the ones that matter, and then you can figure out the other as you get a very skeleton perspective of the working parts of PixInsight. So the very first thing we're going to do is we're going to go to Script. We're going to be going back and forth from processes to scripts. Processes to scripts. We'll use preview and we'll use mask, but for the most part, process and script will be these two categories that we will be pulling all of our tools from. So we're going to go to script, we're going to go to batch processing, and we're going to go over and go down to weighted batch pre-processing. I have probably what will come up is it's going to be already populated with files that I ran the last time I ran this, because it keeps them. I'm going to reset it and clear everything, so we're starting from scratch. One of the reasons why it remembered to bring up my last weighted batch processing run is that I have it ticked right here: save frame groups on exit. I have saved the process law, generate rejection maps, up bottom fits, and include file path to detect masters. I have all of those checked. I have this on auto, and we will pick our output directory in just a few minutes. It'll be the last thing we'll do, where we're going to save all of our files. So at the bottom, from left to right, are choices on how you can add your calibration files and your light frames. Now, when I say light frame, this is the image that you took. And if you took 50 images or 100 images or 30 images, these are the pictures that you took with your camera of your target. We call them light frames, we call them subs, but regardless, if you hear me say lights, I'm talking about the actual image. When we talk about calibration frames, we're talking about flats, darks, flat darks, bias, and those are the files that we need to take in order to better prepare our light frame. Because when you take long exposure images, things happen in the sensor. It heats up, it produces thermal noise, your camera has a signature all of its own. You have different dark currents running through your sensor, you have hot pixels, cold pixels, and you have vignetting, because not always will your camera sensor size match up with your optical train. So in many cases, in fact, in almost every case, I'll have some slight vignetting in my images. So we want to take bias, or we can take flat darks. And I'm not going to explain the difference between the two in this video, but I do happen to take flat darks and I don't take bias. And we take dark frames because these are long exposure pictures, but there's no picture because we cover up the telescope, so it's dark. But what we want to do is take it at the same exposure that we took our light frames, and what we're going to have in it is the noise that's present in the light frame. If we take a dark exposure, one that's covered up, won't have any signal in it, and it goes for 360 seconds, and if our light frame happens to be 360 seconds, then it's going to produce noise, random noise, dark current, and that's going to be subtracted in the calibration process from your light. So it is a way to help combat the noise that's going to be created in a long exposure image. We're going to take flats because flats are going to subtract from your lights dirt, crud, dust bunnies, and vignetting. It will, all the stuff that accumulates on your sensor or on your filters, anywhere in your optical train, your reducer, that will be removed when you take your flat frames. And those are taken by creating a, I'm not going to go into that right now. We're going to go, I have a video on how to, I'm crazy. I'm about to go random again. We're not going into how you take your flats, but in essence, you need a flat panel or a light that covers your telescope that will allow you to take an exposure that will create a histogram that's slightly left of center, and it's covered up. It will be it will produce your dust bunnies, and we're going to subtract that from your light. So don't pay any attention to my definition of all of these things. bias is your electronic signature of your camera, and if you happen to take bias frames, you'll have that same electronic signature in your dark flats or your flat darks. So that's what we're after. So let's add this data, and here's how we're going to do it. We're going to go to darks, and we're going to go to our directory, and we're going to go to, well, we're right here. And I create my calibration frames and build a library of darks, flat darks, flats, and I have flats for different filters that I use. So I also take bias in case I want to use those instead of the flat darks. I'll tell you what I'm going to do. To keep things simple, I'm going to use bias frames in this run. So let me close out, and let's do this. Let's add our lights first. So let's click on lights, and we're going to go to February, and it's the first. We're going to be processing the Cone Nebula, and I happen to have, if you'll look at this title, I have the date, I have the catalog number, an abbreviation of what it is, the cone. My camera's the ASI 533. I have an LX Extreme filter, and the telescope is a 625 millimeter Vixen ED81S. So this just helps me to know what kit I used. And I have two permanent piers with two different telescope systems, and I image two at a time, two every night I image. So this helps me keep the Vixen separated from the stellar view with the ASI 1600 mono camera. So this is a one-shot color camera, this is a mono camera, and so this naming is for me. So here are our light frames, and let's go grab them all. There's 100 of them. I took them with an ASI 533 camera, so you can see that's the naming nomenclature that will come up for mine. They are 360 seconds long. Now it says I don't have a filter because my software has a provision for a filter wheel with LRGB, HA03, and S2, and if I were using that, then that filter would be included here. But I just manually screw the filter on. Actually, I have a holder that holds the filters, and it doesn't know if what I slide in and out. So in that case, it's going to show no filter when I do in fact know I was using the L Extreme filter. So we have our lights. Now let's load our bias, and we're going to have to go back to our calibration frames. And here's our calibration frames for, let's get them all. And so now we have our bias frames. Now it does say rosette, and when I took these, I was imaging the rosette. I forgot to change the name. It's fine. What I want is the bias frame. The name means nothing. It only helps me to understand. Let's go to our darks, and we're going to go back to the Vixen. We're going to take our darks, and when I took my darks, I did this all night long. It was one of those nights where there were too many clouds to image, but there was no threat of foul weather, so I covered up my telescope, and I took 20 15-second darks, 20 30-second darks, 20 45, and I went on up all the way up to 500-second darks. So I build my dark library once a month, and I need the 360, and I took 20 of those. So there they are, and now we have our darks. Our darks should match our 360, should match our darks, should match our lights, and they do. So now we need our flats, and let's go down here. You add down here and you review at the top. And so I used flats with the L Extreme. I also took flats with the L Pro. And since I have a holder, and when I put them in, they go in exactly the same way, I can use my flats over and over again, or until I move my optical train. So now we have flats, darks, bias, lights, and let's look at our calibration data. This is kind of a summary. We see where we have our 100 lights, our 50 flats, our 20 darks, and our 50 bias. So the green checks tell us that we have to calibrate our lights, we have our darks and our flats. In order to calibrate our flats, we have our bias, because you use the bias frame to calibrate your flat. And our darks are checked because you click on this, and this kind of goes bold. That's what it's matched with. Or you click in this, that goes green, and that goes green. So we're all ready to go with a couple exceptions. We show that we know we have a one-shot color camera, but we haven't chosen a color filter array. So what we're going to do is we're going to select our lights, and we're going to go up here, and we're going to tick this box where it says color filter array. And using Sequence Generator Pro with a ZWO camera doesn't write the bare mosaic pattern to my FITS header, so it can't read it. So I have to do that manually. And if you happen to be using a ZWO CMOS camera, the barometrics pattern is RGGB, so it's the very first one. And I want to select apply to all the light frames and confirm it, yes. I have to do the same thing with my flats. I want to tick the box CFA. I want to also separate the color filter array flat scaling, and so I'm going to apply to all flat frames, and we're good to go. So we have, I'm going to make this a little bigger so you can see, we have our color filter array set to RGGB. We have our flats set to color filter array and scaling, and so we're good to go. There isn't anything else here you need to alter. I want to go back to my lights though, and under rejection, apply, uncheck this unless you happen to have some banding, horizontal or vertical, in your final lights. Now I always use a cosmetic correction template, and this is where I load it, but it removes hot pixels, and in this case though, to keep this simple, I'm not using it. Under subframe weighting, select the very first option, point spread function signal weight. Under image registration, click apply unless you're very undersampled, and then you want to generate some drizzle data. But I have a video in my YouTube channel that shows you how and why you should do that. And if you're undersampled or you suspect that you are, go down and watch that video, and that'll clear this one up. And then you want image integration, because what we're going to do is we're going to calibrate and come up with master files for our darks, flats, and bias. Those are going to be calibrated against the lights, and let's see how that works. You don't need to know all of this. All you need to know is how to enter this information. And one thing good about a video, you can stop and start and see that you've correctly done those steps. But if you click on show calibration data, it will show you, I've got the flats checked, that you get a master flat by taking the flat file and subtracting the master bias, and that will produce your calibrated flat. That's what's going to be happening. And you're going to get your master light, because you're going to take your light frame and you're going to subtract the master dark. That's that dark signal that showed up when you covered your telescope and you took a 360 a second blank image. So the thermal noise is going to be subtracted from your light. And then we're going to also divide into your the results of your light subtracted your master dark subtracted light. We're going to then divide the master flat that's created. And remember, we created the master flat by subtracting the bias frame from it. Now, you don't have to do any of this. This is going to do it all for you. But this is what's going on under the hood. And what's going to happen then is you're going to have, when you're finished, you're going to have your calibrated light. And that's what you're going to work on. So now all of this is really the very same step and process that's going on in Deep Sky Stacker when it produces your FITS file. But this is going to do that for you, and it has a lot of other unique possibilities we haven't gone into yet. But this is all you need to know to make a run. Now, for the record, we're going to click on the Post-Process tab. That's kind of helpful. It's going to show you that we took 100 frames at 360 seconds. Our bin was 1 by 1. It says we didn't have a filter, but we happen to know we used the L Extreme. We have the right RGB color space, and we have a total of 10 hours even of information for the cone. And it shows us that we have a DeBayer combined RGB color image. Don't worry about, but leave this at 2. And we have image registration and image integration checked. Subframe rating is automatic. We're using the point spread function. I didn't select the cosmetic correction template. We're going to keep it simple. And I don't have banding issues to worry about, so that's not checked. So let's go down now and let's run this, but I need a directory to put this in. So I'm going to go to, this is my directory, and I'm going to create one. I'm going to call it 1-Pix for PixInsight. And I'm going to call it 1 because I may do this again at another day. And I'll call that 2-Pix because I'll probably want to keep both. In some cases, I have as many as 8, 9, 10 different runs in the weighted batch processing script. Often, I'm just playing around with different options to see if it produces a better final image. So, in my opinion, what we've chosen so far is the best set of options you can pick to run your script and produce a great image. So we're ready to go. If you run Diagnostic, it's going to tell you that we have everything we need, but it will warn you that we don't have a flat dark, and it's going to use the master bias will be used to calibrate our flat. Had we had flat darks, it would have said we don't have any bias. So if you happen to have a flat dark, it's going to remind you don't have any bias frame. Well, we know that. And this is just telling us we don't have any flat darks. Well, we know that. We're using bias instead. And you don't use both. Use one or the other. So we're okay. We're going to run this. It's going to tell us the same thing all over again. We know it, so let's run it. And so down here we're going to watch as this DOS Windows is going to show us the whole process of calibration, registration, and integration. And when it's done, we will do a temporary stretch of the image and see what we have, and then we'll be doing some crops, some dynamic background management where we remove gradients. We're going to do color calibration. We're going to neutralize the background, and then we're going to stretch the image. We're going to run a curves to enhance the colors, and then we're going to do perhaps some saturation in the image. We're finally going to add a noise reduction algorithm, and we're going to save it. And that's what we're doing once this stacking process of the weighted batch processing script finishes. So it's going to take it a few minutes. I'll be back with you when it's done. Okay, we are finished running the script, and you're going to get this dialog box. It's called the Smart Report. And unless you had errors as you look through this, they'll be easy to identify. I think they're in red. But unless you have errors, this tells you that it generated a master bias, and it was successful, and it used all of your bias frames. Same thing with your master dark and your master flat, and then it shows the 100 light frames that were calibrated successfully. So unless you have problems, I would click done. If you click save, all that you're saving really is this smart report. And it's a good thing if you're having problems to save that, because the PixInsight forms are where you would upload the log from this run. And a lot of brilliant people and very knowledgeable people in PixInsight, as well as the creators, can address the issues that you're having and give you some help. So we're going to click done, and we are done. So what happens is that it will bring up the script, and it's time to exit out. We don't need it any longer. And now we're going to go to our file, and we're going to open our completed image. And we're in the cone, and we created this directory, and what we have now are 4 files. We have a master bias that we can use over again the next time we run the weighted batch processing script. Instead of loading all of your bias frames, just load this one, and you'll save a lot of time because it doesn't have to create the master bias frame. Same with your master dark. That assumes that you're using a 360-second exposure, and then here's your master flat. But we're interested in this master light, so we can open this up now. You're going to get 3 images. You're going to get a rejection image called rejection high, and one of the first things that we're going to do so we can look at these is we're going to go up to process. And let's just go down to all processes. All the processes are in alphabetical order. They're also accessible if you know the main category. They'll be included in here. But go to process, all process, and go down to screen transfer function. Here we go, right here, screen transfer function. And we'll get this box. We want to unlink it for the time being, where there are several things here that you can easily access. This is how you reset it. This is how you stretch and look at your image, and this is how you can link the channels. But right now, just keep them unlinked. We're going to stretch it by hitting this auto stretch button. It looks like a nuclear button, and what you're going to see are the highlighted rejections. These are artifacts or trails or something that it picked up. It looks like it was just unaligned stars, but it removed it. These have been removed, so these have been rejected. I don't need that. Rejection low just shows us really where we're going to need to crop. Now, it can show more than that, but in this case it shows us where in the stacking we do have a need to do some cropping, and so we can get rid of that. And then this is our image, and we take a look at that. And this is our cone nebula. So let's make this a little bit bigger. There's a couple of ways you can do that. Down here on the far left, you can click here, and it will make it it will enlarge it to a good working size image. Okay, let's see. The first thing that we're going to want to do is to crop the borders. And so before we do this, I want to label this. I'm going to left click on this tab. Now I'm right click, on the tab. I'm going to go over here to identifier, and I get the option to change this. I'm going to change to RGB, and so this is my starting point. Now I want to make a copy of this and work on the copy. So I'm going to grab the RGB by the tab, and I'm going to bring it over to my desktop and drop it. Now I have a clone. It's RGB_clone. So I'm going to save this, and we'll just put it up at the top. Now let's open this up some, and let's bring up the dynamic crop process. So we're going to go to Process, All Processes, and we're going to go down to Dynamic Crop right here. Now, because there's a likely probability every time that I run PixInsight that I'm going to use the crop feature, I'm going to grab this triangle right here at the bottom left of this box, and I'm going to drag it and drop it, and I'm going to save this process icon to be used over and over again, and I'm going to give it a new name, and I'm going to just put this as DYCR crop for dynamic crop, and I'm going to start building some process icons, and I can close that out, and I can double click here and open it back up. So why am I going to do this? Because I intend to save these. When I'm finished, I'll have a stack of processes that I use to work on this image. I'm going to save each of those processes. I'll create a new process icon, and then we're going to save it by going to File. We're going to go to Process, Process Icons, and we're going to save Process Icons. We'll give them a name, and then when we come back to PixInsight and we start working on another image, we can first go to Process, All Processes, and we can load our process icons. And they'll be in the order that we used them. They'll be easy to access without having to go up here and go on a hunt and peck. So it just makes things easier. And you're going to see some other advantages in just a few minutes why it's a good idea to do these. So we're going to crop this, and let's open the crop feature. Let's reset it, and let's just go over here. When you watch this little box, there's several ways you can do this, but I'm just going to grab the edge there and just scoot it in a little. I'm going to grab this and scoot it in more, and I'm going to grab this and scoot it in a little even more. I'm really kind of framing the image while I do this, and I've got plenty of pixel data, so I can afford to do this. Now I really didn't need to go this far in the crop, and you may not want to, but I chose to go this far. I'm going to go a little further here, and I may even bring this in a little bit more. I do want to keep this star though. Okay, to crop, we're going to go to this green check and execute, and it's cropped, so we don't need this anymore. But you can see we have a lot of green in the corner up here too, and we're going to want to kind of remove some of the gradient that's in this image. So in order to do that, we're going to go to Dynamic Background Extraction, go to Process, All Processes, and go down to Dynamic Background Extraction. Here it is. And we're going to make some setting changes. And hang on a second. We're going to make some setting changes for this. And you're going to want to save those settings, because each time that you open this up, you don't want to have to do this over and over again. And these are some settings that I got from Visible Dark website, Sean Nielsen, and he got them from someone else, and I forget who he said he got them from. But one of the cool things about astronomy is people helping people, And I've certainly been helped by this very fast and easy way to apply a gradient removal. So I'm going to check these boxes to open this up because we have some changes to make. Okay, the first thing we want to do is I want to go down to tolerance right here, and in order to do this we need to reset down at the bottom right. We're going to need to reset the dynamic background extraction. It puts crosshairs on your image, and I want to change this to 2.000. I'm going to change shadow relaxation to 6, and we're going to leave smoothing factor unchecked to the default, and then we're going to come down to default radius size, and we're going to type in 150. Sample rows, 10's good. Sample weight, 0.750 is good. That's the default. You do not need to change anything here, so leave it to the default. And then at the bottom we want to select division, and we don't need a background model, and we want to replace the target image and do not check normalize. I think for this first run, so that you can see what we're going to remove, I'm going to check the discard background model. Now these are our settings, so we're going to click on generate, and we've got a mess of them. I'm going to change the default radius size to 100, and I'm going to resize all. That's better. Okay, so what I'm going to do is I want to delete all but the ones in the surrounding border. So I'm going to click on this, and I'm going to hit delete, 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 delete. Come here. When you first run this, you need to go ahead and do this as well. Okay, now I don't want bright stars in these boxes. These little stars, that's absolutely fine, but I don't want the bright stars in these boxes. So I'm going to go around, I'm going to bring this all the way to the edge. And now keep in mind, I'm going to save this so I can use this over and over again without having to do this each time I bring it up. So here we go. And you may have to do a little maneuvering. I'm going to leave those stars there, that's fine. I'll get away from that one. I'll get away from that one, but it's absolutely okay because you have more background than you have star. Alright, we have a well prepared. I may put one here, and I may put one here. Again, I'm trying to remove a gradient from the background. So what I'm going to do is I'm going to take my triangle, and I'm going to go over here and drop it. And I'm going to change the name, go down to set icon identifier, and I'm going to put dynamic background extraction, and I'm going to put in edges, because what I'm doing is I'm creating a gradient removal using the edges. I'm going to put that process there, which we're going to save when we've finished building our processes. And now I'm going to check the execute box, and we're going to remove this. Okay, I want to close this out, and I want to restretch it. Now I want to come back over here to the background extraction. I want to click on it again, and it reloads just what we had. Remember, we saved it, And what I want to do this time though is I want to change it from division to subtraction. And I'm going to select execute. This helps remove vignetting. And I'm going to close it out. We no longer need it, and we remove the gradients. Okay, so we've evened out the background so that what we have is our nebula, and we do have a color cast, but that's not a gradient. We don't have color changes due to pollution, the very things that caused the gradients in the first place. All right, now our next step is to run a noise reduction script to this linear image. We're going to apply noise reduction twice. This is a linear image, and a linear image is one that is still in its raw form. If you uncheck it, you're still going to have a blank screen for the most part with just a few stars, bright stars showing up. So we're going to stretch this, and now we have an image, but it's kind of noisy. You can see the grain, and we're going to try to mitigate some of that. So in order to do that, we're going to use the multi-scale transformation tool. It's a process, all processes, and I'm having a hard time talking. Multi-scale linear transform. This is what we want. All right, now we've got to really make some changes to this. So what we want to do right away is we have 4 layers selected. So you want to leave it at this at starlit transform. Hang on a minute. Let's see. Yes, just leave it at the default, but you may want to play around with that. We want to change the layers to 5. So now we have 5 layers. We want to leave it on dyadic. We want to leave it on, these are the defaults, linear interpolation. We want to have checked detail layer. We want noise reduction checked. And what we want is to check this first layer. We're going to check all of them eventually, but we're going to start with the very first layer and come down here to the noise threshold and set the first layer to 5500. You can move your slider over here like that, and then up here you have 5500, and you want to change the amount to 0.85. So go here and either type in 0.85 or move the slider down. Iterations will be 1. So now let's go to the second layer, and we're going to change this noise threshold to 3500. And we're going to change the amount to 0.75. Iterations are 1. Let's go to the third layer, and we're going to change this to 2500. And we're going to change the amount to 0.50. And iterations will be 1. We're going to go to the fourth layer, and this is going to be 0.750. And we're going to change the amount excuse me, to 0.33. iterations will be 0. And finally, we're going to go to the fifth layer, click on noise reduction. We're going to change this to 0.500. And the amount is going to be, let's try 0.28, iterations 0. So this is extremely important. You want to check linear mask, and everything else is going to be left alone. You're going to leave it their defaults. We're going to open up though the linear mask, but everything else just leave alone. RGB components, no, everything else is default. So because you're going to want to use this over and over again, and you don't want to have to enter this information over and over again. And by the way, it'd be a good time to take a screenshot of this so that you can enter this information. But we're going to take this triangle and we're going to go over here and drop it, and I'm going to call this multilinear transformation underscore noise or reduction. And it's a multilinear, it's a linear noise reduction algorithm. And I'm going to put that over here, and I'll show you how cool that is. Let's just delete it. And if we wanted to reopen that, if we went to process, all processes, and down here to multilinear transformation, it would come up. But if you go over, if you reboot, it won't come up. If you go over here, it will. All your input will come up the way you want it. Now, here's how you run this. Once you've entered your information, then you're going to, and we want inverted mask selected, then you're going to want to click on let's unstretch the image first. So we have a black screen. Now we want to preview the mask. It's going to be primarily white. And in this case it's black, and we're not going to see anything probably until we move this down. Oh, we need a, didn't know what was going on here. We need, okay, let me get rid of this a minute. All right, anytime that you see a circle down here next to the global execute or apply button, anytime you see a circle, if you click on that, you're going to get a big real-time preview mirror window. So this is a preview view of the mask. We're creating a mask to protect the stars because we really don't want to run noise reduction and smooth out the stars. We want to keep them nice, tight, and sharp looking. And we really don't want to run a lot of noise reduction over our nebula because we want to create some we want to have some definition, some contrast, and some structure with the nebula, but we want some. So you adjust this slider, kind of move it to the right, you'll see more stars and you'll see more nebula, and even more so. And so we're going to leave it about there. So now that we have the mask, then we're going to get rid of this preview window, and we're going to uncheck preview mask, and as soon as this stops spinning up here on the left, take it a second, it's taking longer than a second, then we're going to close it. Now we can come back and stretch the image again, and I want to show you how cool this is. So there's a mask applied because we have it checked here, linear mask. The mask is the one we just created in the preview window. So we're going to drag this on top of our image, and it's going to apply the noise reduction treatment. So kind of keep an eye on this noisy image, and it's going to apply it without applying noise reduction to our stars. Okie doke. So now we have a less noisy image, and we're good to rock and roll. Now we have saved it, so we can delete this. We want to run it. We don't want to run it again, but the next time we run it, it's all populated, so we can close it out. Now the next thing we're going to need to do is to color calibrate this, and in order to do that, we're going to go to Process, All Processes, and we're going to go down to Color Calibration. Now I haven't used this in a long time. I use photometric color calibration, but it involves loading some catalogs, and we're going to use a very simple way to also there's another script called AutoColor that does it effectively, but what I want to do is just show you how PixInsight can take a one of your images and do a very effective job of applying a color calibration. What we need to have, though, is we need to have a preview of the background, and we need to have a preview of a white star that isn't oversaturated. So let's come over here to, let's say over here in this area, and right up here at the top you're going to see a shadow box, a box in the shadow. That's create a preview. And let's just go right up here at the top and create a small preview. Doesn't have to be big. It could actually be very small. So there's our preview. Now I need to kind of find a white star in this mess, and that looks kind of white on the center. Here's a white one here. This one looks better. Actually, it's kind of yellow, but I think I like this one better. So I'm going to let me make sure I haven't oversaturated. I'm going to hold my left click mouse down, and I'm going to kind of hover over this, looking at the bottom down here to see if I have no. All right, let's go ahead and apply one right here. Okay, so we have two previews. We have a preview of a bright star, and we have a preview, a little preview of a area right here that's background. So let's go load them. This is our white reference, which is preview 2. So we're going to go to this little box, and we're going to open up preview 2, find it there, and we're going to go and load up preview 1 on the dark black background reference. So I did it again. Preview 1. So we have our background reference, and we have our white reference. We're going to unclick structure detection, and we're going to just drag this over and drop it, and we will have color calibrated our image. Okay, change somewhat. We can get rid of our previews by going to preview, delete all, and they're gone. So now it's time to stretch the image. So let's get rid of the temporary stretch. Daggone. Let's go to Process, All Processes, Color Calibration. I want to create a, we don't need to save the previews, but I want to create a process icon that we can use the next time we boot up. And this is going to be Color Calibration. So far we have our basic image, and on our clone we've applied a crop, background extraction, applied a noise reduction algorithm, and now we've color calibrated. Now we're ready to stretch the image. So I'm going to get rid of the temporary stretch. I'm going to go up to Process, All Processes, and we're going to look for the Histogram Transformation tool. And the Histogram Transformation tool right here. Now, you see where we have a preview, a little circle here that we can create a preview. Let's go ahead and do that so we can see in real time what's happening when we move these sliders. I want to reset this, and I want to load the image. So it is called the RGB clone. So I have now loaded the RGB clone, and I'm going to take this middle slider. Right now it's the only one we're going to use. I'm going to slide it to the left about there, and I'm going to execute. I'm going to click on the Apply button. I'm going to reset it. I'm going to do it again. And I'm going to click on the Apply button again. I'm going to reset it, and I'm going to do it again. Be sure you don't get into, when it starts sloping up, be sure you don't get into that, because you'll start clipping data, and you want to keep all the data. Okay, we're going to reset it. Now we're going to stretch our black point by taking this slider, and we're going to move it to where everything starts going up. Then we're going to take our midtone slider, and we're going to move it to where the red starts going up, and we're going to click on OK. We're going to reset it. I think we're done. Let me move this a little bit here. We have some blues I've clipped. I hate that, but that's fine. And we're going to execute. We are finished. We can close the preview window. And now I'm going to title this RGB linear. Well, it isn't. We already stretched it. But I wanted to save that before and didn't. But before you stretch it, save it, and you'll have all your steps up to the point where you stretch it. And this is going to be non-linear. RGB underscore non-linear. And I'm going to make a copy of that, and I'm going to put this up here. Okay, we're getting close to getting finished. So here's our cone nebula. It has been stretched, and what we're going to do now is, well, I forgot to save the process icon. Let's go to Processes. Let's go down to Histogram Transformation. And let's drag this over here. Let's close it out. And we're going to change the identifier to Histogram Transformation. And we'll put it up here. So we are now in the last steps. And the two things I'm going to do is apply a curves. I would like to eliminate some of the green that's in the stars. So I'm going to go up to Process, All Processes, and I'm going to come down to Curves, Transformation. Let's go ahead and save this and set icon identifier to Curves, Transformation. And before I go and address the stars, I'm going to I think what I'm going to do first, I'm going to go ahead and delete curves transformation. Let's separate the stars. Let's remove the stars from the image, and we'll just work on the nebula by itself and then the stars. And to do that, go up to Process, All Processes, and go down to StarNet right here. And let's save this icon, and we're going to call this StarNet underscore StarNet star removal. I'll just remind you that you remove the stars from the nebula. Make sure you don't have to change anything, but make sure you create a star mask and then drag this on top of your image. Take you a few seconds. Okay, we have the stars removed and from our nebula, and there's our nebula absent. The stars are most of the stars. By the way, there is a new version of StarNet. It's StarNet version 2, but I use a Mac and it's not yet ready for the Mac. If you have a Windows machine, you can download the version 2 script and put it in PixInsight, and I understand that it does a really smash up, bang up job of removing the stars, but we're going to be adding them back, and those are there for a reason, and when we add them back, they'll all look just fine. So right now, let's work on the stars, because I don't like the green in them, and so what I'm going to do is I'm going to bring up a tool. Let's go back to our curves. I didn't save that. We can delete. Well, let's save this process. Oh, we already did. I'm sorry. Let's delete that then. All right, let's bring up our curves. And what I want to do is I want to check right here. And I'm looking at my curve right here. And I'm looking at where the green and the blue is on this curve. So I think maybe the best way to approach this, though, is to use the saturation tool. So again, I'm going to bury that. I'm going to go up to Process, All Processes, and we're going to work on it's not called saturation, it's color saturation. So Process, All Processes, color saturation. Okay. Now what I want to do now is click this, and this is the color right down here. So when I click this, I can see, when I move my mouse around here, I'm looking at what these colors are, because I want to remove those. So I'm going to set some anchor points here, and I want to set one here where the red becomes green, and then I want to set one about here where the green becomes, let's move this back up, where the green becomes kind of bluish. Then I'm going to set one here where the blue becomes kind of reddish, and where it's really red right there. And so let's find that spot again. It's right here. So I'm going to set a couple more, and I'm just going to unsaturate. Let's create a preview. Here's our little circle, and so we're going to drag this down and unsaturate that. I'm going to pull those colors down a little bit, and we're going to hit it, apply it, and let's apply it one more time. That's good. And so we pulled some of that color out. Is it the best way? No. You don't want to have your stars unsaturated, but it's a good way when you're getting started to forget so much the star color. It's just important that you've got a good looking image. And that's what we're working on. Okay, now let's go. That looks pretty good. Much less. Okay, looks pretty good. I might brighten them a little bit. So let's bring up curves, and I'm going to create a little window, and I'm just going to grab it right in the center, and I'm going to drag it up just a little bit. And I'm brightening my stars, and I'm going to go grab the saturation right here, and I'm going to bring that up a little bit too. Saturate my star colors a little bit. Okay. Now we're going to close that, and we can close this preview window. Actually, I got to do it again because I didn't apply it. I'm doing a heck of a job making this. All right, we're going to click on RGB and our K value, and we're going to brighten it up a little. Not a lot. And let's execute it. All right, let's go to our saturation, and let's bring that up some. And let's execute that. Okay, now we can delete it. We can close out our preview, and let's just call this stars. Alrighty. Just for the heck of it, I'm going to create a clone and save the clone. In case I mess this up, I'm also going to just rename this one cone, so I can easily add it back. And I'm going to take the clone of the cone, and I'm going to save that. So I've got a saved copy. Now let's put our stars right up here, and let's work on our nebula. I did not save the saturation process, color saturation. So let's go ahead and reset this, and let's do that. So this is set identifier, this is color, saturation, so we can save that process. And so what we want to do is let's minimize that for right now. Let's start with curves. Let's go back to our curves. Let's reset everything. And one of the things that I see here is I see the definition of this Christmas tree, and what I think I want to do is I want to see if I can't bring out a little more of the brightness there. So I'm kind of clicking on here. Let me set my RGB values. Let me click on this right here, and I'm looking at where this falls, where the red's falling. The red's falling about right there. So I'm going to set an anchor point about here. I'm going to set an anchor point about there, and let's go ahead and set one about here. Alright, let's create our preview window and play around. So what I'm going to do is I'm going to drag this down just a little bit, and I'm going to start pumping this up some and see if I can create a little more of a definition. Before, after, before, after, before, after, and I'm bringing out some of the blue and some of this definition that I want. After, before, after, before, after. Okay, let's apply that. And now let's go ahead and close out curves, and bring up our color saturation. And let's go here and let's create our preview window. We already have one open, so let's it's red, that means it's open, so let's set an anchor point there. Let's set an anchor point here. Let's work on our blues as well, and we got some teal in there, so let's bump up that a little bit. Let's bump up some of this red color a little bit, and let's give it a boost. Okay, I like it, and let's close that. All right. Okay. I think I'm just going to leave it right there. I'd be working on this a little more, but this gives you an idea of some of the things you can tweak. And the next thing we're going to do, and we have two more things we're going to do, and then we're going to save the image, we're going to save the process icons, and we're going to save the project. So I'm going to go to Process, and I'm going to go to ACDNR. ACD, the very first process. It's a noise reduction algorithm, and here are the settings that you want. You're going to work on the lightness mask, and you're going to have apply checked. You just need to take a screenshot of this. There's nothing we're going to add to the lightness mask. Star protection's checked. Bright side edge protection is checked. And so all we're going to do, you can preview the noise reduction if you want, but I happen to know that it works 99.9% of the time, and if it doesn't, you can go up here where this little arrow points to the left, and you can hang on one second. Okay, now we're going to save the ACDNR, and we're just going to give this a new name too. ACDNR, and NR stands for noise reduction, but we're going to ACDOISEREDUCTION. This will help you remember, or help me remember, what we did, and we can close that out. So running this tool helped, we're going to run it one more time. Helps to eliminate the noise. I don't think I ran it the first time. Okay, here we go. I can tell you if I ran it before, and you can run these more than one time. I did. I had already ran it, so I want to back it out. So I'm going to go up here to the left and click on that and undo that run. Okay, so we're going to get rid of this. We've saved the process, and the last step before saving it is that we want to add the stars back. So we want to put the stars back. So we're going to go up to Process, All Processes, and we're going to go down to Pixel Math. Right here, Pixel Math, and let's go ahead and save this, and we're going to change the identifier to pixel, and we'll put that over here. Now we want to make sure that we have the expression at, we're going to have single checked. Use a single RGB expression. We're going to check that. We're going to click open the expression editor. And what we're going to do is we're going to add the stars to the clones. So clone plus stars. So let's find the word, the clone image. We put it there. Add the plus key and stars. That's all we're doing. We're going to add the clone and the stars back together. Now, you can also use operators and go down here, and you don't have to type in the, here's the plus key. You can just click on this, but at any rate. So we're going to do it again because I just lost it. Expression editor, clone, and it can be in any order, plus, stars, and we're going to click OK. So there we have it, and all we're going to do is, let's go down here, and we're going to create a new image, not replace this one. We want to save that one. And same as target the color space, but let's just go ahead and make sure it's RGB. That's all we're doing. Let's drag our triangle over here, and now we have added the stars back, and we can close this out. We've saved Pixel Math over here. Well, I have some regrets, but you got the idea. The regrets are that I brightened the stars. They're a little bit too bright. I did remove a lot of the green. I could have removed more because we had some here, but there we go. Now, in order to save this, I just go to File, Save As, and I'm going to, I don't want to save it in that master folder, so I'm going to go to the right here where the root of the run, and I'm just going to type in cone. No, I don't want a new directory either, a folder. Let's just go here and type in cone nebula, and it's going to be a TIFF file, but you can make it anything you want. And I'm going to make it a 16-bit unassigned integer because I'm going to take it into Photoshop, and that'll be another day. And so we have saved the image. Now I'm going to go to File, so I'm going to go to Process, Save Process Icons, and I'm going to click on Save Process Icons, and I'm going to go to my this image, and I'll just save them right in here, and I'm going to call these EDS. Edge Process Icons, and it saved them. So I can delete them now, and I can go up here to Process, All Processes, Process, Process Icons, Load Process Icons, and I can go to February, Stream, Edge Process Icons, and load them, and there they are. So now I have this available when I open up a new image, and I can start in this order and run through these steps, and everything's been set up for us. But I also want to save this as a project, so I'm going to go to File, Save Project, and I'm just going to call this the cone, and I'm going to find a directory to save it in, and I'm going to put it in the same place where we have our other files, and we're just going to click Save. Okay. Okay, we've saved the project, and so let me show you how that works. Let's close out PixInsight, and now we're going to open it again. It's good to save your projects because at times, you know, you'll start working on something and you'll get partially through it, and you're hoping that you can finish it, but you don't have time, so you end up closing it, shut down the computer, save the project, and when you come back a day later or 2 days later, a week later, you can go up to File, Load Project, and then go over to your target. We're in February, and here's the cone project. Click on OK. Okay, we're loaded. And that's it, folks. Make sure you save your process icons and you can reload them. We're ready to produce, put our image up on the Facebook or wherever, Instagram or wherever you load them, and share them with the world. Now, we only talked about several processes, but these processes are all you need to take an image from beginning to end. And but I would recommend that you pay attention to the fact that PixInsight has all these other processes, and they're there for a reason. They can do some amazing things for your image. It's just powerful software. It has as much horsepower pound for pound as Photoshop does. And I didn't think there was any software in the world that could outmatch the horsepower in Photoshop. So with that being said, I would appreciate that if this is helpful, that you like and you subscribe, and by doing so, I get the feeling that they were helpful, and that means something to me. I hope that they are. Thank you for watching, and have a great rest of the day, and make sure you say something kind to somebody. You're going to feel better for it, and you're going to make their day.